Hello and welcome to the Algebra 2 PLC. We're going to continue discussing Unit 2, Topic 3 with a focus on SLT 21 in this segment. I'm James Key.
And I'm John Chase. Welcome back. So let's dive in first to SLT 21, the first activity in SLT 21, which creates a discussion around an activity called the gift. Hannah is buying a gift and she wants to split the cost with her friends, and the total cost of the gift is $360. She's planning to split the cost of the gift, and the question is, what would happen if you split it over a whole bunch of friends versus a small number of friends? For teachers familiar with inverse variation, this should give rise to a very nice inverse variation model, and that's what you'll be taking kids through first.
Yes, indeed. And clearly, the more friends that are involved, the less each person has to contribute. And so, as we transition into the next activity, we're taking a more abstract look at the mathematics of inverse variation. Students are presented with the statement, the product of two real numbers is 1, and they're asked to write an equation that represents that statement. And so this equation could be used to model the situation. They're also asked to write it in such a way that y is a function of x. And so we have this related equation here. And in producing the graph of these equations, students should be prepared to grapple with the questions, what happens to y when x is very large or very small? Let's go ahead and take an in-depth look at those questions.
First of all, the original model, I think it's worth exploring with students, both the form we started with, xy equals 1, but also y equals 1 over x. These are both worth talking about with our students. In the first way, it's actually kind of makes sense. We have 1,000 times what equals 1? 1,000 somethings equal 1. What would that be? Well, it seems natural to us in our mind that that would be a thousandth. In fact, that's a great name for something that 1,000 of those things makes 1. Or over here, we have one, we could think about it in terms of we have one whole pizza and we're dividing it among 1,000 people. Well, how much does each person get? Well, not very much is the answer, 1,000th of a piece of pizza. So that's a good exploration for how we might think through out loud what happens when x gets large. What about when x gets small?
Well, let's take a look. So if x is a small number, let's say 1,000th, we can look at 1,000th times what is equal to 1. And it should be clear that you need 1,000 thousandths to make 1. So when x is 1,000th, y must be 1,000. And as John mentioned, even though we recognize that mathematically these equations are equivalent, and the mathematics of these processes are equivalent, for students it might feel different to be thinking through a situation like this. So when presented with the expression 1 divided by 1,000th, let's just have some questions prepared for students that might be struggling to compute that. So for instance, this really asks, how many times does 1,000th go into 1? And clearly the answer is it goes in 1,000 times. Either way you slice it, when x is 1,000th, y is 1,000. And of course, keeping the big ideas in mind, we want students to recognize, and kind of summarizing the discussions there, when x is a large number, the value of y is small, whereas when x is a small number close to 0, the value of y is very large. And in particular, we looked at the example when x is 1,000th, y is 1,000, as well as the fact when x is 1,000, y is 1,000th. In fact, there's a certain symmetry to this pair of ordered pairs. And there are actually lots of interesting features with the graphs of this. John, do you want to talk a little bit more about that?
Sure. And as we go to create this picture, obviously I think it's for most Algebra 2 teachers, it's our practice to go slowly and look at the global behavior over time, plotting some points. And I think it's worth taking the time, like we were just doing, even though it seems kind of a little bit slow moving, to talk about, look, well, let's stop and think about what is 1 divided by 1,000th. But it's a question that we don't maybe wrestle with and we just rush through, but our students maybe do wrestle with that. What is 1 divided by 1,000th? So fractions within fractions, that's tricky. So as we approach the global behavior, let's not like minimize the fact that like as we plot points, we're plotting something that's familiar, but to the students, this is cool. This is a very cool new thing. As we plot this, we're getting a horizontal asymptote and a vertical asymptote. We've seen functions now when we did log and exponential functions. We've seen functions that have a horizontal asymptote or one vertical asymptote, but this is new, the fact that it has both. So I think it's worth like highlighting how cool a new function this is, and also worth highlighting and asking, letting the question arise in your own students' minds, hopefully too. Questions about symmetry. Is this odd? Okay, neat. Well, can you prove it? And what about the inverse? The fact that it's its own inverse, I don't want to like give anything away here, but the fact that it's its own inverse is tremendously interesting, and I don't know that we've met a lot of functions that have that property yet. So that's worth discussing with your students. We can classify this equation as odd. We can think about both of those last two statements in terms of symmetry. Symmetry over the line y equals x, and also rotational symmetry with respect to the origin. We also, every time I like to think about, if we're still in the mode where we're starting to complete a graph of this, and every time we're plotting a point, every time we plot a point, like here's the point, for example, 2, 1/2. Well, every time we plot a point, we get 3 other points for free. We get this point, if we recognize the symmetries, we get this point for free, 1/2, 2. But we also get these 2 points down here for free. We get -2, -1/2, and -1/2, -2. And so that question should kind of arise in your students' minds. It should, again, be kind of exciting that we get 3 more points for free every time we plot 1 point. And we should let those questions arise naturally as they come up in class, too. Maybe we don't push these on students, but we encourage students who might start to be noticing these symmetries to be like, oh, really?
Yeah, definitely lots of interesting features to consider. As you're talking, it occurs to me, not only is this graph symmetric with respect to the line that's shown y equals x, it's also symmetric with respect to the line y equals -x. You could fold the plane along this line, and the 2 halves of the graph would match up as well. The last comment that I wanted to make here, in terms of classifying the graph, as teachers we recognize that this is a hyperbola, and students in honors geometry will have studied hyperbola, and so a challenging question that we can ask, that's surprisingly difficult to answer, by the way, is where are the foci of this hyperbola? Can we identify the coordinates just on the basis of the equation? Is it possible to identify the coordinates of those foci? Lots of great things to consider in looking at inverse variation and the equation y equals 1/x. We hope that this overview of SLT 21 has been helpful to you. And in our next segment, we'll dig into SLT 22.
Thanks.